Hello viewers, my name is Dr. Ajay, Associate Professor, Department of PCE, Institute of Aeronautical Engineering College, Hyderabad. And today we are going to discuss the topic on problems on end-fire array. So today's topic is problems on end-fire array, and these problems are related to the course Antennas, Waves and Propagation. So let us start our session today. An end-fire array of identical antenna consists of 4 isotropic radiators separated by a lambda by 2. So find the radiation field in a plane containing line of array showing the directions of maxima and minima. Or in another way, the problem can be asked as the obtained positions of maxima and minima of the radiation pattern for end-fire array. So here we need to design an end-fire array which contains 4 isotropic radiators, and all the elements are separated by a distance of d is equal to lambda by 2. So we know that an end-fire array is nothing but the radiation pattern will be along the axis. It will be along 0 degrees or it will be along 180 degrees. If there are 4 elements here, the radiation pattern will be along the axis. But in broadside array, the radiation pattern will be maximum perpendicular to the axis of the array. So here the end-fire array is nothing but where the radiation is maximum along the axis of the array. We call it as an end-fire array. So along the 0 degrees and along 180 degrees, the radiation pattern will be maximum for an end-fire array. Now let us design the end-fire array for 4 elements, and let us find out the maxima and minima points. So here we know that according to the psi is equal to beta d cos theta plus alpha. So psi is equal to beta d cos theta plus alpha. Here the psi represents the total phase angle of all the elements of an array, and alpha represents the phase angle between any 2 elements in an array. And beta is the propagation constant 2 pi by lambda, and d is the spacing between the elements lambda by 2. So here we know that the end-fire array is nothing but the radiation will be along 0 and 180 degrees. So we need to satisfy this equation to get the radiation pattern either in the direction of 0 or 180. The psi value, the total phase angle must be 0, and theta value must be, suppose let us take theta as 0 here. Why? Because this is 0, this is 90, this is 180, and this is 270. The radiation pattern will be either in the 0 or 180. So beta d cos 0 plus alpha. So this is equal to cos 0 is nothing but 1. So here alpha is equal to minus beta d. So cos 0 is equal to 1. So alpha is equal to minus beta d. So what is beta here? Here beta is minus 2 pi by lambda into d. So minus 2 pi by lambda into d. So here we are getting the value of alpha, the phase angle between the elements as 2 pi by lambda into d. Suppose if I say the spacing as lambda by 2 here, we know that d is equal to lambda by 2. So minus 2 pi by lambda into lambda by 2. So this is equal to lambda get cancelled, and 2 to get cancelled, this is equal to minus pi. So alpha is equal to minus pi. So alpha is equal to minus pi radians. So minus 2 pi d by lambda, where d is lambda by 2, you will get alpha is equal to minus pi. And if at all, suppose if d is lambda by 4, then in this case alpha becomes minus 2 pi by lambda into lambda by 4. Lambda get cancelled, minus pi by 2 radians. So for different spacing of elements, we need to determine the value of alpha. We need to determine the value of alpha here. So the phase difference is pi, the phase difference is pi by 2 for the spacing of lambda by 2 and for the spacing of lambda by 4 respectively. Now let us find out the maximum values. Direction of pattern maxima. Let us find out the values. We know that sine n psi by 2 is equal to 1 if sine psi by 2 is not equal to 0. Now n psi by 2 is equal to plus or minus 2n plus 1 into pi by 2. So from this equation we will find out the value of psi. So psi is equal to 2 by n into 2n plus 1 into pi by 2. Here small n represents the number of sources and capital N represents the number of major lobe maxima. Major lobe maxima. Here, if we assume the radiation pattern, these are known as lobes. So this is in which direction and this lobe is in which direction. We need to find out in which direction this major lobe maxima are there. So we represent this as n is equal to 1 or n is equal to 2. So how many number of lobes we need to represent as n by capital N value. So psi is equal to 2 by n, 2n plus 1 into pi. Pi by 2. If we cancel this, you will get 2n plus or minus 2n plus 1 by n into pi here. So like this we can simplify here. And here we know that psi is equal to 0 here. And psi is equal to beta d cos theta plus alpha here. This is equal to plus or minus 2n plus 1 into pi by n here. So here we are going to find out the value of psi here. We can find out by substituting beta d cos theta. We are going to find out the maximum value. So I am writing as max value. The value of alpha is minus beta d. So we have determined here. The value of alpha is minus beta d here. So we are going to find out the minus beta d here. So beta d cos theta max minus beta d is equal to plus or minus 2n plus 1 into pi by n. Into pi by n here. So from this equation, you can take the value of beta d common. We can take the beta d value as common here. So beta d into common as cos theta max minus 1 is equal to plus or minus 2n plus 1 into pi by n here. So from this equation, you will get cos theta max is equal to plus or minus 2n plus 1 into pi divided by beta nd plus 1. So this is the equation we got here. So let us further simplify. So here we are getting cos theta max as plus or minus 2n plus 1 divided by beta nd plus 1 here. So from this equation you can find out the value of theta max is equal to cos inverse of plus or minus 2n plus 1 by beta nd plus 1 here. So we need to find out for a different, according to the problem, n is equal to 4 it is given, the number of radiators. The d is equal to values, d is equal to lambda by 2 here. Now for these two values, we shall find out the value of theta max. So theta max is equal to cos inverse of plus or minus 2 into 1 plus 1 by 2 pi by lambda into what is the value of n? 4. D is equal to lambda by 2 plus 1 here. Let us take here n is just 1 here. First maxima. For first maxima, let us assume n equal to 1 here. Here lambda get cancelled. 2 1s, 2 2s here. So 2 plus 1 is equal to 3. So 3 by 2 plus 1 you will get. So you will get 2n plus 1 into pi here. So pi get cancelled here. So if you simplify this, you will get cos inverse of plus or minus 3 by 4 plus 1 here. Plus or minus 3 by 4 plus 1 here. So here we can write as a cos inverse of 3 by 4 plus 1, 1 and cos inverse of minus 3 by 4 plus 1 here. So we'll get two different angles here. So here we'll get cos inverse of 7 by 4 comma 1 by 4. So 7 by 4 will not exist. Why? Because the value of cos maximum function is 1 here. So 7 by 4 means 7 by 4 is equal to 1.2. So but the cos function is, the maximum value is only 1 only. It is never greater than 1. Hence 7 by 4 will not exist here. Hence we are going to consider only the values of cos inverse of 1 by 4 only. So we are going to consider only the values of cos inverse of 1 by 4. So that is cos inverse of 0.25 you will get. So 1 by 4 is nothing but 0.25. If you simplify this, you will get 75.5 degrees. And another one is cos inverse of 7 by 4. So cos inverse of 7 by 4, it is greater than 1, so it does not exist. So it does not exist. So theta max, we are getting one major lobe as 75.5 degrees centigrade. So similarly, we are going to find out the second major lobe maxima. Second major lobe maxima for n is equal to 2 here. So for n is equal to 2, let us go into substitute in theta max 2. Let us assume this as theta max 2 here. So we know that from the equation, we know that theta max is equal to cos inverse of 2n plus 1 into pi, 2n plus 1 into pi by beta nd plus 1. So this is the formula we have derived here. So from this equation, theta max of 2 is equal to cos inverse of 2 into 2. Why? Because we are going to consider the second pattern maxima. Second maxima we are going to calculate. So capital N is taken as 2 here plus 1 into pi divided by beta is 2 pi by lambda into the value of n is lambda by 2. Sorry, the value of n is 4 here, beta nd. Why? Because the number of sources is considered as 4, d is equal to lambda by 2, and this is plus 1 here. So lambda get cancelled, 2 ones, 2 twos get cancelled, and we are getting here 4 here, pi get cancelled here. So if you simplify here, you will get cos inverse of 2 twos are 4, 4 plus 1 is equal to 5, 5 by 4 plus 1, this is plus or minus. So for this again we are having two values here. One is cos inverse of 5 by 4 plus 1, comma, the other one is cos inverse of minus 5 by 4 plus 1 here. So here minus 5 by 4 plus 1 you will get 5 plus 4 is equal to 9. 9 by 4 here, one function. And another function is minus 5 minus 4 minus 9 by 4 here. So here, this will not exist here. So 9 by 4 means it is greater than 1. So this function will not exist here. 9 by 4 it is approximately 2 point something. So we can derive this equation. Cos inverse of minus 9.4 here. So minus 5 by 4 plus 1, you will get minus 1 by 4 here. So here, one positive, one negative, minus 5 by 4, 4 point minus 1 by 4 here. So here you are getting minus 1 by 4. So for this minus 1 by 4, you will get cos inverse of minus 0.25 here. So we are going to get cos inverse of minus 0.25. So if you simplify this, you will get minus 75.5 degrees. So minus 75.5 degrees. So this is theta max 2 here. So here theta max 2 is equal to minus 75.5 here. So like this we can find out the number of maxima by substituting the value of n is equal to 1, n is equal to 2 here. Now let us find out pattern minima here. Directions of pattern minima. So in which directions the minima, the directions of pattern minima, in which directions the nulls are there, or in which directions there is no radiation pattern. So we are going to find out again from the same expression, beta d cos theta. Let us, as we are going to find out the minima, we are identifying this as min. So we are writing this as min cos theta min plus alpha is equal to plus or minus 2n pi by n. So from this we are going to find out the value of the cos theta min here. So beta d cos theta min is equal to plus or minus 2n pi by n minus alpha. So here cos theta min is equal to 1 by beta d into plus or minus 2n pi by n minus alpha. So from this equation we can also simplify 1 by beta d into plus or minus, so we know that alpha is equal to minus beta d. Let us substitute beta d here only. So here beta d cos theta min minus alpha is equal to minus beta d. This is equal to plus or minus 2n pi by n. Let us take beta d as common. So cos theta min minus 1 is equal to plus or minus 2n pi by n. So cos theta min minus 1 is equal to 1 by beta d into plus or minus 2n pi by n. And cos theta min is equal to plus or minus 2n pi by beta nd plus 1 here. So from this equation, theta min is equal to cos inverse of plus or minus 2n pi by beta nd plus 1 here. So from this equation, we are going to find out the beta d value 1 minus cos theta, and we are going to further simplify this by applying the trigonometric functions here. So here you can write here as cos theta min minus 1 is equal to plus or minus 2n pi by beta nd. So 1 minus cos theta. So this can be written as cos theta min can be written as 1 minus 2 sine square. 1 minus cos theta is equal to 1 minus 2 sine square theta min by 2 minus 1 is equal to plus or minus n lambda by nd here. So why? Because if you simplify this, plus or minus 2n pi by 2 pi by lambda into n into lambda by 2, lambda get cancelled, and here 2 get cancelled, here pi get cancelled. Okay, if you simplify this, you will get n into d here. So here nd, so plus or minus n lambda by nd here. So if you further simplify this, you will get sine theta min by 2 is equal to root of n lambda by 2 nd here, plus or minus. So theta min is equal to by 2 is equal to sine inverse of plus or minus square root of n lambda by 2 nd here. So for this equation, let us substitute the values of n is equal to 4, d is equal to lambda by 2, and n is equal to 1 here. So n is equal to 1 indicates the minor lobe minima here. So for this equation, let us find out by substituting these values here. So let us find out the first min value. So theta min is equal to 2 sine inverse of plus or minus root of n is equal to 1, lambda is lambda, 2 into 4 into lambda by 2 here. So if you simplify this, you will get 2 sine inverse of plus or minus 1 by 2. So this is equal to plus or minus 60 degrees. Plus or minus 60 degrees here. So like this, we need to find out the value of theta min 1 here. And similarly, you can also find out theta min 2 here. Theta min 2 stands for n is equal to 2 here. So n is equal to 2 here. So just substitute here n is equal to 2 here. So if you substitute n is equal to 2 here, so you will get 2 into plus or minus 45. So this is equal to, you will get plus or minus 90 degrees. you'll get plus or minus 90 degrees. So similarly, you can find out for theta min 3. So you can find out by substituting the value of n is equal to 3 also. So n is equal to 3. If you substitute 3 here, so you will get 2 into, you will get the values as, you will get approximately for 3 as plus or minus 120 degrees here. Plus or minus 120 degrees. So like this, we can find out a number of values by substituting n is equal to 1, n is equal to 4. So if you simplify this, for n is equal to 4, the same equation. So for n is equal to 4, you will get 180 degrees plus or minus 180 degrees. For n is equal to 3, you will get plus or minus 120 degrees here. Right? So like this, we need to find out the minima values. So we got the minima as plus 60, plus 90, plus 180, plus 120, minus 90, minus 120, and minus 180. So these are known as the minimum values we have determined for n is equal to 1, for n is equal to 2, for n is equal to 3, and for n is equal to 4. So these are known as minima, and we need to represent them in the form of equation diagram here. This is theta is equal to 0. This is theta is equal to 90. This is theta is equal to 180. This is theta is equal to 270. Our radiation pattern is maximum here along the direction of 0 and 180. Why? Because it is an infrared array. And here we are going to represent the values. The minimum values are 60 here. This is 45. This is 60. And this is 90 here. This is 180. There are 4 sources here. Represent these 4 sources. And 60 here, 90 here, and this is 180 here. Let us indicate as dot. And this is 120. This is minus 120. This is minus 60. This is minus 120. So like this, we need to indicate the minimum directions where there is no radiation pattern in the infrared array. Also, we have seen that the major lobe maxima are in the direction of 60 and 75.5. That means in the direction of major lobe maxima 60, and here there is 75.5 here. So you can write like this. This is 60 and this is 75.5 degrees. So this is minus 60 and this is minus 75.5. So like this, we need to draw the radiation pattern by representing the maximum values and minimum values for the infrared array of 4 isotopic radiators. So these are the equations just now we have derived here. Our psi is equal to beta d cos theta plus alpha. So the radiation pattern maxima can be determined by these equations. You can see in the equations of whatever we have did just now. You can see in the equations. So alpha is equal to minus beta d, we have found out. Psi is equal to beta d cos theta max of min plus alpha. So here theta max of min indicates minor lobe maxima. So minor lobe maxima means, so these are major lobe maxima. This is major lobe maxima and this is minor lobe maxima. These are minor lobe maxima. So we indicate as this function theta max of min here. So if you simplify this, alpha is equal to minus beta d, you will get the value of theta max as plus or minus 2n plus 1 by beta nd into pi by plus 1. So we know that beta is equal to, let us from this equation we know that the number of sources is 4, d is equal to lambda by 2, and let us substitute these two all the values. You will get one minor lobe maxima. The other one is again if you substitute n is equal to 2, so we will get another minor lobe maximum minus 75.5 here. And similarly, we can also find out the directions of pattern minima. So beta d cos theta min plus alpha is equal to plus or minus 2n pi by n. So from this, you need to find out the value of theta min here. So by mathematical simplification, if you simplify, you will get the theta min as 2 sine inverse of plus or minus root of n lambda by 2 nd here. So for n is equal to 1, for n is equal to 2, for n is equal to 3, and for n is equal to 4. So we need to find out the values of theta min 1 and theta min 2 for n is equal to 2. For n is equal to 3, theta min 3, we need to find out here. So you are getting the plus or minus 120, plus or minus 120, plus or minus 90, and plus or minus 60 here. So after getting all the values, minor lobes and minor lobe minima and major lobe maxima, so we're going to draw the radiation pattern here. So for this problem, we need to refer the textbook KD Prasad by antennas, waves and propagation, or you can also refer the UA Bakshi antennas, waves and propagation. So let us close our session today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.